Hey everyone, in today's video, we're going to be exploring which static seal is better for leak repair, graphite rope packing or copper tubing. These are the primary static seals that are used within the industry. So I figured we better explore the pros and cons of each one and ultimately determine which one is the best. So in order to do this, I figured we'd get real engineering and we would create what's called a weighted decision matrix. The criteria I'm going to be using to evaluate these two seals are the ease of installation into the enclosure, the durability of the seal, how hard it is to compress the seal, chemical compatibility, temperature rating, and pressure rating. I've given each of these a weight due to their importance or my perceived importance of the different criteria. So for example, ease of installation, I've given that a 1, which would be the lowest weighting, and 3 would be the highest. The reason I did this is because for me, the performance of the seal is more important than how hard it is to install it. Other things to consider as well are the durability. You want to make sure that the seal is highly durable, so I gave that one a weighting of 3. How hard it is to compress, I gave that a weighting of 2, because if it's a little harder to compress but it works, well, that's fine, but we like something that's easy to work with. Chemical compatibility, this is important, but it's not the most important because most leaks are steam leaks or water leaks, etc. We do get into some extreme chemicals, but if you're focusing on the majority, then chemical compatibility is not a huge thing. Temperature rating and pressure rating are all very important considerations as well. That's my weighted decision matrix. Now let's get into talking about how we're going to evaluate each one of these. So starting with ease of installation, what I did is I took the copper tubing and I tried to place it in a groove. So what I did is I bent it around this ring to try and fit it inside a groove. And then what I had to do is I had to cut it and try and form it a little bit more to get it to fit perfectly. It was a bit of a pain. I've heard in the industry that this is also a pain. And so anyways, I validated that that is true. It took me probably 2 or 3 times longer to mess around with the copper tubing than it did with the rope packing. With the rope packing, I was able just to lay it in the groove fairly simply, cut it with an X-Acto knife, and then squeeze it in, and it was essentially done. So it was super, super easy. The one thing I didn't show with the copper tubing was soldering it in, which would be another additional step that can take a little bit of time. And so in general, the copper tubing was much more difficult to work with, even though we're working with annealed copper tubing that is somewhat flexible. So when it comes to rating this, I'm going to give the copper tubing a rating of 1. It was not great to install it. And the graphite rope packing, I'm going to say that was a 3. It was super, super easy to do. So in terms of ease of installation, which again has the lowest overall weighting, the copper tubing was by far more difficult than the graphite rope packing. So the next thing to evaluate is durability. So what we've heard from technicians in the field is that copper tubing is susceptible to being dented upon installation. So I essentially wanted to validate that that was true. So I took the copper tubing and a hammer, swung at it lightly. Sure enough, it dented. You can see that it dented and it didn't spring back. So one issue with that is if you're installing this copper tubing into an enclosure and you're shipping it to site, then if it gets dented or banged or anything, then there's a good chance that that seal is going to be damaged. Now, if it gets damaged, you're going to have to pull that seal out, grind it out, and then go through the whole process of trying to install it again, which can be painful as we showed earlier. Now, I did the same thing with the graphite rope packing, hit it with a hammer. Sure enough, it dented a little bit, but it was not nearly as dramatic as with the copper tubing. Now, this is not a super accurate and scientific test, as of course I'm not hitting it with the exact same force, whatnot. But in general, just from a light swing, the copper tubing was definitely more susceptible to taking permanent damage than the graphite rope packing was. So I'm going to give the copper tubing a rating of 1 here for durability, and I'm going to give the graphite rope packing a rating of 3, which makes that one the winner in this test. The next thing I evaluated was how hard it is to compress these seals. So how much force does it take to get the seal to fully compress and have your enclosure come together? Now, one reason that this is important is because you want the seal to compress almost all the way to flush, if not all the way flush, so that your bores on the enclosure come completely together and you get a tight seal. Now, you don't want to have to use excessive force, because if you have to use excessive force, then you need bigger bolts, etc., and bolting equipment. So it is important to try and minimize the amount of force it takes to compress the seal. So I took the copper tubing that I'd formed into my little ring and I put it on our press, and essentially I squeezed it until it came close to flush. Now this was using a 1/4 inch tubing and a 1/8 deep groove, so I was trying to compress it to 50% of its initial height. Essentially with the press, took about just over 2 tons of force to get the copper tubing to fully compress down. Did the same test with the graphite rope packing, got up to over 5 tons before it got close to flush. But we have done other testing in the past, which has shown that it's almost impossible to take a standard 1/4 inch graphite rope packing ring and compress it to 50% of its initial height. It just won't go that far no matter how much force you put on it. The copper tubing was much easier to compress than the graphite rope packing. I'm gonna give that one a 3 as the winner here, and I'm gonna give the graphite rope packing a 2. It wasn't impossible, but it was somewhat difficult. So the next thing we're going to look at is chemical compatibility. With this one, I didn't do any testing, but I can tell you a little bit based on my research and experience about what we've seen. So graphite rope packing tends to be a much more inert material than copper tubing. It can be used in most applications, and there's seldom a case where we see that it cannot be used. There are some cases where strong oxidizers like nitric acid or hot concentrated sulfuric acid can attack graphite, but these are exceptions to the rule of graphite being a very inert compound. Copper tubing, on the other hand, is a metallic material, so it is susceptible to galvanic corrosion, to being attacked by ammonia or ammonium-based compounds. Also can be attacked by strong oxidizing acids and sulfurous environments. So in general, in terms of overall chemical compatibility, graphite is going to win this competition. So what I'm going to do for that one is I'm going to give the copper tubing a rating of 2, and I'll give the graphite rope packing a rating of 3. Now the next thing is temperature resistance. Our industry standard for copper tubing is to use it up to about 450 Celsius or 842 degrees Fahrenheit. With graphite rope packing, typically we'll use it up to 550 degrees Celsius or 1022 degrees F. Now that being said, it can be used up to 1200 degrees Fahrenheit according to most manufacturers. I'm going to give the copper tubing a rating of 2, which is still pretty good, and the graphite rope packing a rating of 3. Now the next thing I want to look at is the pressure rating of these seals. So in our industry, we will typically use copper tubing up to 1500 PSI, whereas with graphite rope packing, typically we would stop at 350 PSI. Now, according to most graphite manufacturers, they say that you can use it up to 3000 PSI in valve applications, which would be similar to a leak repair enclosure, as they're both static. The main reason that there's this difference and that packing is rated so low is because of what we would call blowout resistance. So when you're installing these seals inside of an enclosure bore or in the grooves that go around the perimeter, and you're installing that enclosure over a leaking pipe or whatever it is, then as the enclosure comes together, it can build up pressure. And if it's a very high volume leak, you can have a tendency to actually blow the seal out of the groove, and that can cause big issues. So that's why traditionally graphite rope packing has been rated down so much from the manufacturer's spec. Now that being said, what's become a common practice is to use an epoxy or simply Gorilla Glue like this to glue the packing into the groove. I haven't actually heard any test results from that, but I have heard practically that it is preventing blowout in a lot of applications. In this case, I still can almost guarantee that copper tubing is going to be more robust because it's soldered into the groove, whereas even if you're gluing the rope packing, probably still has a tendency to rip out. So I'm going to give copper tubing a rating of 3, graphite rope packing a rating of 1. So that concludes our comparison of these two seals. So let's see which one actually edges out and wins. So our total value with a weighting for copper tubing ended up at 29 points, and graphite rope packing came slightly ahead with 34 points. Honestly, wasn't a huge difference. Practically what I can say is that the graphite rope packing is used 10 times more than copper tubing with leak repair enclosures today. It's just much more common. It also has a tendency to mushroom a little bit better when you're actually installing it. You can see here how it flattens out and mushrooms, and so it creates a wider seal. So maybe that's giving the technicians a bit of an edge. So overall, this is a tight race. I did want to mention that even if you tend to like graphite rope packing more than copper tubing based on this discussion and this analysis, always check with your technician or the company that you're working with to find out what their preference is for your specific application. Don't hesitate to ask them questions about their preference, but they often will have a reason for why they're picking a particular type of seal, and they may deviate a little bit from what I told you here based on their own expertise and the way that they install leak repair enclosures. As I mentioned, don't use this chart verbatim. Check with the technician and make sure that you can come to an agreement with them about why they're selecting their particular type of seal. Anyways, thanks for watching this video. I hope you learned something. I found it quite interesting to do a couple of these tests myself. So if you enjoyed it, check out some of our other videos, and thanks for watching.